Hello everyone, welcome to Domain 8, Cloud Workload Security. A cloud workload is a related set of software and data that are deployable to some type of infrastructural platform. An example would be a software package that is running on a virtual machine or a container or a function as a service. In this domain, we will discuss about unit and platform on which they are deployed. This also aligns with our discussion on risk specific to the workload and how is the responsibility being treated or the risk is being treated between cloud customer and the provider. So let's proceed. So this one is the eighth domain out of the 12 domains, cloud workload security. In this domain, we are going to discuss about what are the challenges of creating security approaches for a cloud security workload. So whenever you have a workload, what are the challenges? What are the unique parameters you can define? Okay. Also to understand security related concerns to a virtual machine or securing a container or a security of the platform. Even you will discuss about serverless and function as a service as a workload. And lastly, it also covers AI workloads. So let's proceed with the next slide. Okay, so the first topic is about what is a cloud workload. That's very important. As you know, cloud workload can be anything. It could be a platform, it could be a virtual machine, a network construct, or it could be any application which is running. So these are individual workloads which we can define. Okay. In cloud, the best thing we have is agile and adaptability. That means they are quite easy to configure, they are easy to create, delete, modify with a simple code. Okay. And on top of that, they all, or I would say all the projects have a different or unique requirement. We can't say one size will fit all. So that approach is not effective anymore. Okay, so you know your workload, you can define your workload. It can be dynamic, it can be static. They could be very complex. That means you can host a simple websites and you can also have a total ERP system running on it. Okay, so new types of workload which has been introduced is function as a service or a container. This is more towards making the application more agile and keeping them loosely coupled. When I say loosely coupled means they can be defined. The workloads can be defined and can be removed by different functions. So that adds loosely coupled, not like in on-prem where you have everything predefined. You can't modify, you can't adapt to new boundaries. So, to discuss further, as I said, cloud workloads, virtual machines, definitely. These are the base, or I would say the building blocks. So where you have a host which is provided by cloud service provider. On top of that, you are setting up your own virtual machine, which is kind of a construct, is an operating system, and you can have your own application on that. Then comes in containers. Containers, as I mentioned, it is loosely coupled. So you have a base OS which is controlling all these containers, and these containers can hold your functions. They can actually perform a simple hosting website like an Apache web server. So you can have a container with that. FaaS is function as a service. This is uh, these days kind of used very often because of the construct. So when I mean you have a function, but you don't need to deploy the underlying operating system and an application. So what you need, you have a function, you just want to run the function. So what you can do is you can define this function and you can host it on the cloud service provider, or you can provide them or ask them to run this function on their environment, and it counts by the number of run. Okay. On top of that, now we have AI workloads which process a large amount of data. It poses its own security challenges. So this one we'll discuss later. It is coming in the next slides. So in order to have, or I would say, what can impact or what controls you can put in places, you can actually have EPP, EDR. EPP is like anti-malware, host intrusion prevention systems. Then you have file integrity monitoring, application control. EDR is more towards user behavior. So you can have or you can install agents which are cloud aware. When we say cloud aware means they are being tested, available in marketplace where they can be, have been proven that they are working, and then they can manage the cloud workload, the dynamic or the static nature. Okay. Then monitoring, definitely key part, as we discussed in previous other domains. You have to capture all the logs. Mostly all those are not all the logs, most of the logs which they are generating. whether it will be network connectivity, what is the function being run, who is running it, authorization, audits. So all this is required. Then you perform audits, you conduct vulnerability scannings of your virtual machines as in on-prem as well. But now you're also performing assessment of your containers. That means what images you have in your repo, how they are being, created. Are they being, all the ports are being closed, or only relevant ports are open? So you can perform an online and offline assessment of these containers and virtual machine. You can also read about cloud workload protection platforms. More or less, what I found is they are far or less they are related to the set of security tools or security functions which can be provided by any platform, a single suite to cover all that. Okay, thanks a lot. Let's move forward. Okay, so securing virtual machines. So as I mentioned, virtual machines are a full operating system running on a hypervisor, commonly used for cloud workloads due to their proximity to hardware and widespread familiarity. There is strict isolation between workloads and across different customers. And each virtual machine operates on its own. That means it's a full construct with an operating system, with an application, its own network cards and all. So what are the key challenges? So the key challenges is how you secure your base image. So whenever you are creating a virtual machine, is your virtual machine being created using a script, or you are using any kind of base image, or is a pre-prepared or pre-baked image, a vanilla image. So have you versioned it? Is it immutable? You can't go and modify that. Patch management, are we patching it on a regular basis? What is our attack service, unnecessary components, or performing any hardening configuration? Access control, always practice least privilege principles. That means provide access only what is needed, not more than that. Automation, try to automate your patching, your reporting, your creating of your virtual machines, or versioning them. So it is more less prone to human errors. Configuration management, try to use infrastructure as a code. That means you perform or create your infrastructure using a code. You can write cloud formation, you can have Ansible, you can have a couple of other things that can be used to create all these virtual machines. Monitoring and logging, as we have been emphasizing, you have to track the activities, you have to centralize it. All the logs are controlled or set to a central location as SIEM solution, where they have the logs, where you have a single console where you can modify or create use cases. You can have your alerts, you can events and all that. Okay, moving to network security, definitely you need to use a host based firewall as well, while you are using a network based firewall or an IPL, network intrusion prevention system, detection system. But you can also, or you should have, a host base. In the previous slide we talked about EPP, so that's an example. Secure boot, TPM, or protect your machine against pre-boot attacks. That means the machine is booted up and then the certain code is included, and that's is kind of a malware. Okay, a specialized tool could be monitor your hypervisor, because hypervisor is the entry point for any virtual machine. So if your hypervisor is compromised, there are high chances that your virtual machine is also compromised. So in order to move forward, the VM deployment, actually you should start with a standard base image. You should have a consistent security configuration. Use the feature of auto scaling whenever you want to include or expand. Use the immutable workloads. That means you use the same image or consistency across all the image. Even if you do an auto scale, you have three nodes running. You maybe have two nodes or another three nodes. They all should be of same version, so that gives you efficiency, that actually helps you to troubleshoot that it could not be a problem, or it could be a problem, but so that helps you to narrow down the problem. Okay, also, leveraging on the right tools is very important. That means whenever you're performing or creating your secure images or virtual images, so you actually have to use very logically. So there's something called image factories where you actually assemble and customize your virtual machines. You automate this process. So you keep creating, assembling, setting up the same virtual machines again and again. Image sources, that means okay, there's a difference between image source and and talking about the virtual machine. Okay, so virtual machine is a full construct. Image could be a vanilla flavor. So that means I provide you with a vanilla flavor, and then on top of that you install your application. Okay, so this could be image sources. Also includes your operating system, applications, libraries, configuration files. So understand the difference between the point where you're doing an assembly rather than and then you are creating. So it's more of a image source is more like a recipe, while image factory could be the baked the meal. Okay. Again, then similarly, the best practice is like you do have to do the hardening, use CIS benchmark, patch management, regular patch management. Uh, Patching is available, Windows patching is there, Linux patching is there, middleware patching is there. Then configuration management, ensure your configurations are all documented, logged as well. Okay. Validation and testing, very important. You have to do unit testing, regression testing, integration testing. You have to perform that part. So in order to leverage or any kind of, you can look for a vulnerability management program. So what it will include is you can have your traditional vulnerability scanner, which might not be effective as in cloud, but again, there are similar products or types which are available for cloud as well. Configuration management, as I mentioned about EDR, endpoint detection and response, they are the one who actually perform vulnerability assessment on subsite. Okay. So in order to there's a very important thing I think I missed on writing it over there is about snapshots. So snapshots is something which are very crucial in all your environments. So what you do is whenever you have a virtual machine, maybe you're performing a change, you can take a snapshot. Snapshot will be in point uh, uh, state of a virtual machine. When you take a snapshot, you nearly actually definitely you are consuming storage, you are consuming space on your system. But again, they actually prevent you from uh, unforeseen situation. You got into a problem, your application not working, you want to revert back, rollback plan. So snapshot can be used for that. But do note, snapshots are not backup. Snapshot is just a method where you want to just take a point in time. Okay. Again, in order to mitigate all these risks is stringent controls. Snapshot creation is there, but make sure that you delete them on time. They have to be protected, they have to be encrypted, they have to regularly review. Another key point is whenever you take a snapshot, the data keeps growing, so you have to merge the snapshots. That's another important thing. On top of that, monitoring tools definitely to perform who access, or if somebody is trying to access to your snapshot and then try to recreate, or understand or doing a reverse engineering. So all in all, yes, uh, securing virtual image or virtual machine image is all about creating a consistent and repeatable process. So that is the key to securing a virtual machine. Thanks a lot. Okay, securing containers. So in this section, actually, we'll drill into the importance of building secure container images, how to orchestrate our containers efficiently and safely, how to manage security challenges arising with containerization in environment. Also, what is a comprehensive or securing each step of container lifecycle? That means creation, deletion, and modification, and how to protect your container images by which you are creating your containers. So but first of all, what is a container? So container is a very light executable package that includes everything you need to run for an application. To make it very simple, let's say you want to run an web server. So what you need for a web server, you need an Apache, you need a website, whatever, and then you need a page. So what you have, everything packaged into one, and then you just run a copy of that container, and that's it. It also got network, it got the binaries, executables, maybe your configuration, everything what you need to run it. So you just have to get a copy of the container, and then you can run it on your environment. Okay. So how it is done? It is actually all the instructions are done in a Docker file. So you create a Docker file that actually helps you to provide consistency and portability. So you can create a Docker file. You can move that Docker file to other locations. They can actually be used, reused. Okay. Also, containers should use a base security images. That means the images, again, as I mentioned in virtual machine as well, the images should not be mutable, immutable. Okay, meaning once they are built, they are deployed and they are not modified. So if you want to replace them, you have to create a newer version or newer images. Don't re-edit or keep editing the same image. So that's what we call. So what you do is after you have created those images, secure them in a repo. So this called as an artifact repo where you actually essential all these images safely. Okay. So if you see, Kubernetes is one of them, and actually it provides you network isolation, and then you can have different load balancers. So if you see the image, What is there is a node 1 and node 2 which is running. Let's say you have a end user which is connecting through the load balancer so that it can distribute the the traffic across node 1 and node 2. So node 1 and node 2, they are running on cube server, cube app server. Okay, so kubectl is the command line, so you actually manage your cube app servers using that. It's all Kubernetes called as K8. And so you have a container. It actually provides you with all the runtimes. And then this is, if you see, is the dotted line is all managed through your platform automatically. Okay, the container managing platform. Okay, so the important thing you need to understand is how about networking. So networking is heavily relying or is an extension of your host operating system. So that means you have a hypervisor, then you're running Kubernetes on top of that, and then you're running containers of that. So that means your Kubernetes is the one which is managing your network, the inbound, outbound, ingress, egress traffic for you. Okay, so it's more of an extension of your host operating system. So again, in order to have security, you have to leverage on cloud providers. So these days, let's say AWS, Azure, they all provide you with Kubernetes. You just have to define the Docker image. You push the Docker image, they take care of rest of the things. Okay. Again, when you define your images, make sure that unnecessary features are disabled. The services which are of no use, you should disable them. The ports. Similarly, do regular patching, update of the component. The binaries get vulnerable on time. Your packages, uh, maybe using different binaries, they get vulnerable or outdated, so have to replace them or patch them. Okay, define a security policy. What kind of policy when we refer to is how the network connection will be, what will be in, what will be out, what are the ports used by the user to connect. Let's say they are connecting at port 80, but internally your container is using 8080 8080. So this is how you do the mapping. So the benchmarks, if you want to define, you can use CIS benchmark. They provide you with a lot of documentation about how to secure your containers, specific details. So you can use that. Again, you can have your repos, private repos, not a public repo, private repos with the RBAC role-based access control. Who can download, who can create, who can modify. So those are key important. Again, configuration, secure configuration. You can again use the benchmark CIS. Host security. So as you know, everything is hosted on this platform provided to you. So you have to make sure that your host is also secure. So more or less, this feature is sometimes definitely managed by the cloud service provider. But as a customer, you have to ensure that yes, you have done your due diligence, maybe run a vulnerability scanners to validate that. Okay. Now, next part comes in the construct is the storage. So the data storage happens not on the container itself, it goes to a separate location. So make sure that it's encrypted while in transit, while in rest, or you have access controls, you are monitoring it. Then you have network security, the firewall rules are stringent, you have to check. You have the segmentation because they all are loosely coupled, but again, you have to define the rules nicely. Okay. At last, then you have the image validation. So whenever you are pushing up any image or you are creating any workload, what you can do is within the CI/CD pipeline, you can actually have a kind of testing mechanism where you see whether your the image use is signed. If the image is signed, then only use it. If it is not signed, then we don't use it. So it could be possible that a malicious threat actor has actually placed a image, but that is not signed. So that way you can actually uh, ensure that your image is validated and correct image to use for. So these are the key things, I think, kind of important things. These days we are moving towards containers, and I think virtual machines sooner or later will be only for specific use cases. But I can see containers functions are being heavily used. So I think take your time, go through this slide, make a maybe request you to take a photo of this and keep it handy with you. Okay, thanks guys. Okay, before moving to serverless, let's complete a little bit more on the containers. When you perform any kind of runtime protection for the containers, you can use for real-time visibility. What is the usual behavior or of a container? How the user container is created? What are the key ports it gets connected? If you see something unusual behavior, you can actually create some kind of alerting mechanism. Logging an audit, definitely you need logs to do a post-incident review in case you have anything. Micro-segmentation is all talking about loosely couple all your containers and is actually isolating containers to contain the breaches. Let's say one of your node has got compromised, then you should have a way to isolate it, contain it, and then keep it for forensic purpose as well. And container specific firewalls, yes, you can actually have firewalls rules between the container towards the host going outside, the way it connects to the load balancer and how it connects overall. So you can define container specific firewalls. Then automated response, you can use a SOAR, which is a security operation feature where it actually addresses all the risk and actually can do the mitigation on its own. Okay. So moving to serverless or function as a service. So serverless computing is a way of in which a developer write and deploy code without handling the underlying infrastructure. So you don't have to worry about the infrastructure. As I mentioned earlier, you just need to have a piece of code or a function. You actually use it, and then that will be managed by your cloud service provider. So the cloud provider manages the servers, which includes provisioning them, scaling to a different loads, and maintaining them, and let the developer only focus on coding without worrying about the underlying work that goes into server management. This shift away from a traditional focus on infrastructure means development only pay for the computing power they use, often built down to exact number of milliseconds to code execution, number of service invocations. Okay, so the primary advantage of server computing is operational simplicity. That means you only worry about the code, nothing about the infrastructure itself. So developers provide the code provider take care of rest of the things, and including all the operational aspects like system maintenance and scalability. So the system automatically adjusts computing resources based on the application needs, provide a highly flexible and efficient solution for developers who wants to build and scale applications quickly and with minimal overhead. So, nevertheless, developers must remember that despite the cloud provider assuming many of the security responsibility, they still secure the application code, efficiently manage access controls, safeguard the sensitive data, transfer to and from the function. So customer has to be responsible for the access management and for the data. The cloud service provider will not be taking that responsibility for you. Okay. So I've added this uh, diagram or image. I got it. So how does a virtual machine, a container, and a function they all uh, align? So function, as I said, is just piece of code. If you encapsulate this function into a container and then you can run it in a different way, it could have a runtime or real time. Then you can even generate something as a dynamic action or something. Okay, then if you have a virtual machine is more heavier. When I say heavier means it got more moving parts than any of the container of the function. Okay, so as we mentioned, the key issues you have is a third party service, and then your application interface, any kind of misconfiguration, excessive permission, direct internet access. I have seen a lot of people managing or creating functions which have direct access to the internet. No, you have to route it through a firewall, through a load balancer, maybe through a proxy, so that you don't have a direct internet access. Okay. Also, always try to have least privilege and fine grained access control for your functions. Don't just give admin rights so that you can function can perform anything that can be really lethal. Okay, again, always use the environment variables. Try not to do any kind of hard coding of the passwords or the API code inside the code or API keys in the code. So try to limit. All these things come with a pinch of salt. So you have to understand that how do I manage my virtual machines, how do I manage my containers and my functions. But my suggestion will be, as we are moving or adapting to more versatile agile applications, functions is the way to go. It can reduce heavily on your thing. To give an example, a lot of people ask me, what does can you give me a quick example? Yes, the moment you actually remember, if you go to Facebook, you actually upload a full image, then you suddenly see a thumbnail. Okay, what does happen? What happens exactly? So what is happening is your images are sent to a function. That functions create multiple formats or views of the same image. It could be a thumbnail, it could be a smaller size. So this is how a function, this is the easy and realistic example I can give you, which more or less everyone might have used. You go to Facebook, you upload a picture, then you suddenly see a thumbnail. But when you click on the picture at the back end, it goes and retrieve the actual image. Okay, so this is how a function use. Okay, pretty nice. Actually, you should be focusing more or study more about functions. It will be really helpful. Thanks a lot, guys. Okay, artificial intelligence, the buzzword for these days. So, artificial intelligence drives transformation changes in our lives and work. Okay, by enabling machines to learn data, simulate like a human intelligence. And AI workloads include tasks from product remediation to vehicle piloting, extensive data, computational power, specialization hardwares like graphic processing units and tensor processing units. These workloads benefit from cloud environment dynamically scaling capabilities. Also, AI helps in automating tasks, in enhance customer experience, solve complex problems. Also, understand and manage AI workload is crucial for maximizing AI's potential with a lot of focus on data, algorithm time, real-time processing of innovation. Okay, so CSA has developed the CSA large language model, which is a taxonomy that establish a common taxonomy and definitions of key terms related to risk scenarios and threat to large language models. Okay, the goal is to provide a shared language and conceptual framework to facilitate communication and alignment within the industry. The document defines the following risk categories. Okay, so before we move into the to the risk, we have to understand what are the threats to any kind of AI system. So the key one I've actually highlighted. Make a note of this very important one. So model manipulation. You have a large language model which the threat actor can actually try to detect and manipulate. So that's it will be producing an inaccurate and misleading results. Then data poisoning, you have a inject a false information, error or a bias based information to the original data set, to that is called data poisoning. Then you have sensitive data disclosure, because your large language model can actually extract or data from different sources. If it is not configured properly or not defined properly, it can also lead to leakage of sensitive information. The model theft, the entire LLM model what you have created, it gets stolen or it gets replicated or is used by the malicious actor to do notorious things. Okay, model failure or malfunctioning, definitely I'm talking about a failure towards the software side or the hardware side. Let's say there's a software bug, there's a hardware failure, there's a hallucination. So we talk about there is a key thing called as hallucination in these large language models. Okay, operational errors. So these are the model failures. Supply chain, because more or your ecosystem is managed or using any third party components. If they are compromised, they are not secure, definitely your whole entire ecosystem is on a stick. Again, insecure plugins, you have vulnerability introduced through a plugin. You were using a plugin that was used by a developer, and then that plugin itself has some was compromised, and then that was used against the large language model or towards that service. Again, denial of service, as we say, it's an overwhelming response to with a high volume, or it could be intentional. Mostly is intentional, where you actually create traffic which looks legit, but it's the purpose is to reduce the efficiency or degradation of the service, or that actually lead to loss of trust. Again, non-compliance to regulatory requirements. Maybe you have PDPA, but your LLM model actually has or more or less the data which you can't be shared. Okay, so these are the key things, or I would say the key threats to the systems. In the next few slides, we'll actually talk about more. So let's proceed. Okay, so when we talk about the AI ecosystem, which is very complex, evolving, and multifaceted, okay, it actually involves different actors, service, technology providers, and then they have their own responsibility with the AI service, okay, or in the supply chain. It also likes, there's when we say shared responsibility is the same model as we introduced, but there are more parties involved into this. Okay, so defining the responsibility and allocating them between a AI provider or consumer is really very crucial. So in this one, as we discuss about the risk, we already have the threat actor. Now we talk about what are the risks or the risk posed by those threat actors. Now we see how we can actually use or perform risk mitigation in an AI environment and what are the shared responsibilities. So to start with, data security. So data has to be encrypted. Actually, that leads to the data confidentiality. Data in transit, data in storage, at rest or in transit, it has to be encrypted. Okay, definitely randomize your data. So that actually helps you with differential privacy. When you randomize the data or you pseudo randomize it, the record cannot be traced back to any person or to someone. Okay, that actually helps you to mask or you don't mask private data. Now again, coming back to multiple sources, because you are performing or you're engaging multiple parties, it's good to have some kind of secure computation. When I say is means, you can, when you interact with different parties, you can anonymize the data, you can do a tokenization. That means the data is not available because you're coming from different sources, multiple sources. Okay, again, coming about the trusted execution environment, wherein whenever you're performing or processing your data, the data should not be open and wide. That means somebody can extract it while it is being processed. So how the next one is model security. How do you actually ensure your model is secure? So in order to secure your model, definitely you need the resiliency. If your model is resilient, it can actually defend against different attacks like DDoS attacks. Robust training, that means you keep improving how uh, your the AI model is responding to the queries. Is it right fit? Is it actually using the right technologies? Is actually helping to solve the complex problems? Okay. Then you also need to do an adversarial training. That means against an attack. Let's say purposefully try to it's like a learning counter. So that means there are wrong commands being processed, or they are actually being uh, the commands thrown by a threat actor. So does it actually can handle that? Can you identify a legit query and illegit query? Can it understand what kind of data is being asked? Can it actually deny those things? And then yes, then how? Okay. Again, modeling watermarking. Definitely all your assets, even if it is your model, it's actually an asset. How to define the ownership? Have you done a watermarking? Do you have a hashing? Do you have something in place which can identify that this data belongs to certain member? Okay. Output manipulation. Okay, it's more towards identifying how your LLM does the analytics. So that means, let's say you have pre-built a game, a poker game, but the player can bluff the poker. So how do you actually do those things? So kind of very, very, new things coming in with AI. And the next slide will also talk about the same. Let's move to that. Thanks. Okay, in continuation to the previous slide, then we have infrastructure security. You have GPUs, graphical processor units. What you have to use is the hardware-based security, the inbuilt security. So that means the code cannot be executed at the pre-boot, or it is isolated. So these kind of things, even you can have a regular security firmware upgrade that's mandatory to have. Then you also have security network measure, how these things are interconnected. Okay. Then again, AI services, again, real-time monitoring, access control, who is managing what components and all that. So that also comes under infrastructure security. Quotas and rate limiting, very important one. Quotas and rate limiting is actually helps you. Let's say somebody tried to use your chatbot example, your chatbot against your organization. So how you do that? So number of questions being asked, number of queries being resolved. So put a pause, put a quota that you can have 10 queries, 13 queries, or something of that sort. The rate at which the queries are coming in. So all this comes into infrastructure security. The last but not the least, supply security or supply chain security, very important. More or less your LLM is actually based on third parties. There is component which is evolved through multiple different third party services which you're consuming. So definitely define how you actually have a supply chain. How do you ensure that you are performing a regular audit and update on the third party itself? Are they performing it? And if they are performing it, how are you validating it? Again, are you performing any security assessments on your own, or it's a self-based, or it's a third party, or it's an internal audit? All those things within your organization and within the third party. Okay, trusted sources. So always try to have reputable sources. Don't try to, we have sources from uh, parties which can be, a free or open source. But open source doesn't mean they are not reputable. The point I'm trying to make it, there should be a check and balance. So that means there is someone, let's say they created a very good function, but that function was or that binary was never updated for a very long time. So do you want to use it? Is it still trusted? So those things you have to make a choice. Okay. So again, proactively monitoring these threats definitely helps out to fight against any kind of emerging threats and protect your AI systems. So all in all, I find this one very useful, and I think you once you go through this, make a note of. I think slide number 7, 8, 9 are my favorites. They are more talking about AI, which is something a lot of people are still not very much familiar. So I would suggest go through slide number 7, 8, 9, and then yeah, soon my other domains will be out. Thanks a lot, guys. Okay, I want to thank you again. So like and subscribe the channel, and I will be adding more videos soon. Thanks a lot.